Hello and welcome to our Unit 3 test review. And the first question I have on here to determine whether the relation is a function and give the domain and range for this relation. So first things first for the function, each one of those x values goes to a different y value. So this is indeed a function. Then for the domain and range, the domain would just be the numbers 4, 5, and 7. While the range are the numbers 1, 3, and 7. For the second question I have, determine whether the relation is a function, give the domain and range. This one now, we have 4 mapped to both 1 and 6, and 7 to also 1 and 6. So this is not a function. The domain for this one, since we list the 4 and the 7 twice, the domain is just 4 and 7. And the range, same idea, would be 1 and 6. For the third one, we want to determine whether the relation is a function, give the domain and range. All those x values go to different y values. Nothing's repeated, so yes, this is a function. The domain would be, let's see, -7, -6, -5, and +5. While the range is going to be also the same, -7, -6, -5, and 5. For the fourth one, we want to find the indicated function values for this function, 2x² plus 4x minus 5. So we want f of 0, f of 2, f of -3, f of b, and f of 4a. So starting with f of 0, this will be 2 times 0 squared plus 4 times 0 minus 5, which should give us a value of -5. For f of 2, this would be 2 times 2 squared plus 4 times 2 minus 5. And that would give us a value of 11. For f of -3, this is 2 times -3 squared plus 4 times -3 minus 5. And that should give us a value of, +1. For f of 4a, let's say for f of b first, actually. Let me go in order. Replacing all the x's with b's. So 2b squared plus 4 times b minus 5. And then for f of 4a, 2 times 4a squared plus 4 times 4a minus 5. So multiplying everything and simplifying, this will make 32a squared plus 16a minus 5. And the last question on this page, this function below is defined by two equations. The equation in the first row gives the output for negative numbers in the domain. The equation in the second row gives the output for non-negative numbers in the domain. We want the indicative function value. So this is one of those piecewise functions. F of x is 4x plus 6 when x is less than 0, or 7x plus 8 if x is greater than or equal to 0. So f of negative 6, 4 times negative 6 plus 6. That is going to give us a value of negative 18, since that was in the first part. F of 0, because of the second part having, including the 0, this is going to be 7 times 0 plus 8, which is give us a value of 8. For f of 5, since that one's positive, it's the second equation. 7 times 5 plus 8. That's going to give us a value of 43. For f of negative 100, that's that top equation. 4 times negative 100 plus 6 is negative 394. For f of positive 100, the second equation, 7 times 100 plus 8, so 708. And then we would add those two together to make 314 for that one. So that's it for part 1 of this Unit 3 review. Be on the lookout for part 2. Thank you. Welcome to part 2 of the Unit 3 review. Graph the given functions f and g in the same rectangular coordinate system. Select integers for x starting with negative 2 ending with 2. Describe how the graph of g is related to the graph of f. And we have f of x is x squared, g of x is x squared minus 9. So let us build a table. So we want x values of negative 2, negative 1, 0, 1, and 2. So since f of x is x squared, we're going to square each of these x's. This is going to be 4, 1, 0, 1, and 4. And then for the second part, we are subtracting 9 each time. So negative 5, negative 8, negative 9, negative 8, and negative 5. And then let me make this a bit bigger here to hopefully see it nicely with this very small graph. For this, we would have a point at 0, 0, at 1, 1, negative 1, 1, and at 2, 4, and negative 2, 4. For that. And the graph looks something like that. This is for F. And then for G, let me use a different color. It's green. This would have a point at 0, negative 9. 1, and negative 8. Negative 1, negative 8. And then 2, negative 5. And negative 2, negative 5. My point was slightly off. So something like this. So the how G is related to F is just translated it down by 9. Um, translated down by 9. For number 7, use that vertical line test to determine if y is a function of x in this graph. You could draw a line anywhere. Does not matter where. It's going to hit the graph only once, so this one's a yes. The second one, using the vertical line test to determine if y is a function of x. This one, if we drew a line anywhere here on the first or fourth quadrant, it's going to hit the graph more than once, so this one's going to be a no. Thank you for watching the second part of the Unit 3 review. Please be on the lookout for Part 3. Thank you. Welcome back to Part 3 of the Unit 3 review. This ninth question here, using the graph of f to complete each of the following. So based on this graph here, and I'll do my best to have it up here most of the time. There's multiple parts on this one, so please bear with me. The first one, we want the domain of f. So this goes off in both directions. So this is all real numbers, or negative infinity to positive infinity. The range, the smallest value of the range is at -9. And it includes it. So bracket -9, and it continues going up to positive infinity. For the C, we want f of 2. So if we look at where 2 is on this graph, it's about there, which is a value of 7. The values of x for which f of x is equal to -8. So negatively all the way down here. Hits at these 2 points there and there, which should give us a value of 7 and 9 for those values of x. Letter E wants the points where the graph of f crosses the x-axis. So that happening on there and there. It's a value of 5 and a value of 11. So 5, 0 and 11, 0. For f, the point where the graph of f crosses the y-axis. So it crosses the y-axis there, which is a value of 7. 0, 7. The values of x for which the function is less than 0. So that's anywhere between where 5 and 11 are, anything below those. So it's below the interval of 5 to 11. Not including them because they're right at 0. Is f of -7 positive or negative? We don't know what -7 is. It's someplace off here to the left. But since this arrow here is pointing to the left, presuming it stays the same, it should also give us a value of 7, which would then be positive. Number 10 there on the bottom. Find the domain of the function f of x equal to 6x plus 6. This is a polynomial, and all polynomials have a domain of all real numbers. So negative infinity to positive infinity. Thank you for watching part 3 of this Unit 3 review. Please be on the lookout for part 4. Thank you. Welcome to part 4 of the Unit 3 review. We want to find the domain of this function f of x equal to 11 over x plus 12. The only thing we have to restrict is where that denominator is equal to 0. And that only happens when we have a value of x being -12. So an interval notation, that would be from negative infinity to -12. parenthesis, union, negative 12 to infinity. Find f plus g of x and f plus g of 2 when f of x is 3x squared minus x minus 1, g of x is x minus 5. So f plus g of x. This is going to be 3x squared minus x minus 1 plus x minus 5. So combining these like terms, those x terms cancel out. This just leaves 3x squared, negative 1 plus negative 5, minus 6. And then when we pop 2 into that sum, so f plus g of 2, this is 3 times 2 squared minus 6. So 3 times 4 minus 6, 12 minus 6. This gives us a value of 6. Number 13, find f minus g of x and f minus g of 7, where f of x is x squared minus 3x and g of x is 9 minus x. F minus g of x squared minus 3x minus 9 minus x. This will make x squared minus 2x minus 9. And then popping in the 7, so f minus g of 7, 7 squared minus 2 times 7 minus 9, so 49 minus 14 minus 9 will give us a value of 26. With f of x being x squared plus 5x and g of x being 3 minus x, we want f times g of 5. So if we put 5 into f, 5 squared plus 5 times 5, so 25 plus 25, this makes 50, and g of 5 is 3 minus 5, makes negative 2. So f times g of 5 would be 50 times negative 2. And that should give us a value of negative 100. And then this last one, f of x is x squared plus 9x, g of x is 2 minus x. We want f divided by g of x. And this you cannot simplify. So it's just x squared plus 9x divided by 2 minus x. And f over g of x of this being 3 squared plus 9 times 3 over 2 minus 3. So that's going to give us 9 plus 27 over negative 1, so negative 37. Let me know if you have any questions or concerns. Thank you.